So, good afternoon, and many thanks to the CyCon team for a great 3 days. So, my name is Pete Cooper, and I'm honoured to be here with a great panel that's right at the cutting edge and crossover of two areas which are absolutely critical to us, which is cybersecurity and space. We're fully dependent on both, and when we look at where they overlap, there are some really fascinating and pressing challenges. And I'm honoured that throughout my career I've been able to keep a handle on being involved in both, through either being involved in, for example, the Shreve War Games, or being involved in the aerospace village at DEF CON, and working with the great hacker community industry and different governments about how do we look at the cybersecurity of our space assets. And when we look at the growth of our connected digital ecosystem, we can see that right across all of our sectors, the challenges of securing what we value against our adversaries that are resourced, innovative and determined is that there's nothing off limits. And a satellite is literally just a digital connected computer that happens to be physically inaccessible just because it's in orbit. And there's been a significant growth in that space sector, both in launch vehicles and payloads and satellites. Now, it isn't just nation states that we are seeing such a diversity of stakeholders getting involved, because that now ranges from commercial to academic. So innovation in both satellites and launch vehicles is now bringing down the cost of getting payloads into orbit. And it's now no longer one payload to one rocket or one launch vehicle. If there is a physical space and launch vehicle, that can be sold to multiple stakeholders for multiple payloads to reduce costs. So as an example, SpaceX, even on their recent Starlink deployment, had 2 rideshare satellites or payloads, and then another rocket earlier this year had 143 satellites on board. So the world of getting payloads into orbit has completely changed. But what does this look like? What does this mean if we look at it through our cyber and adversarial lens? So this panel is going to start exploring that overlap of space and cybersecurity and where those challenges can multiply, so cyberspace cubed. So how much trust is required to strap somebody else's satellite to your rocket? In this panel, we're going to delve into those questions and then what that means across the intersection of cybersecurity, space, collaboration and risk. And we're going to start with a presentation from James, with a paper that he and the team at Oxford have written exploring a novel threat model that targets some of these implicit trust assumptions when we're looking at our multi-stakeholder space community. And then that presentation will be used as a launch pad for an open discussion on challenges in securing these new space missions, the tensions between the interstate collaboration and competition in orbit, and also the evolving role of both technologists and policymakers interested in defending that final frontier, and how we need to actually work together to achieve those secure and trusted partnerships that we're looking for. So, as an intro to James, James Savor is a DPhil student and a Rhodes Scholar at Oxford University's Department of Computer Science, and his research focuses on satellite cybersecurity and ways to secure modern systems and modern space missions from emerging trends. And what's great is that I keep bumping into him and his great work, either at the Aerospace Village at DEF CON or the cyber strategy competition I founded at the UK. And it's great to see him here at CyCon. And I'm going to pass over to him for a great presentation on the research he and the team came up with before the panel. Thank you.
Thanks. So I'm really excited to be presenting today and kind of starting off this panel talking about some research that we've been doing in partnership with Armasuisse, looking at a really exciting topic, which is this, rocket launches. And in particular, what's happening at the top of this tube full of fire. And this image here is from the European Space Agency's Vega mission, which launched last year and carried 53 satellites on a shared journey towards the stars. And if we peel back the payload fairing at the top of that rocket and look inside, we see a really complicated and fascinating global world. We see satellites from giant US tech companies like Facebook. We see research projects, whether that's from a university in Tallinn or a nuclear physics institute in Moscow. We see startups in Argentina, Slovenia, Israel, all involved in this rocket. We even see governments. The Thai Air Force was sending a satellite on this same vehicle with all these other people. And if you think about the relationships between these states and these entities, you can understand that there's some significant trust dynamics involved in sharing this journey to space. Today, we're going to look a little bit at threat models in that domain and what happens if one of these participants is malicious and wants to somehow compromise or undermine the security of the space mission, maybe by inserting their own payload with hidden behaviors in its code, or by manipulating the behavior of someone else's payload so that it can cause harm to the overall operation. Before I get too into that threat modeling, though, it's important to have a basic understanding of why states and companies are doing this ride-sharing thing at all. So if we imagine that you're a satellite operator and you want to launch your satellite into space, the first thing you'll do is acquire a rocket or a launch vehicle. And we'll say it costs like $150 million. You put your satellite on it, and then you realize there's a problem here, which is that you're not really using all of this enormous, expensive rocket. Your satellite isn't heavy enough to push it to the maximum of its capacity. So you call up your friends in the space industry and you say, hey, I've got this rocket I'm launching. Any chance you want to hitch a ride? And your friends will split the cost with you and attach their secondary payloads to your rockets. We've gotten really good at this cost-splitting sharing model. In particular, we've been developing smaller and smaller satellites over the past decades called nanosats or Cubesats. Some of them are literally the size of a Rubik's Cube, and we can basically just keep cramming these on into rockets until we've used up all of the available space and launch capacity. And this is a win for everyone involved. The Cubesat owners would be absolutely absurd for them to spend $150 million to launch their Rubik's Cube worth of computing components into space. So they're able to send these smaller, cheaper experimental projects at a cost that otherwise would have been impossible. Meanwhile, the larger operators can subsidize the cost of their space missions by selling out this wholesale launch capacity they have, cutting into their own risk and increasing their ability to innovate and launch new satellites. Today, we're going to look at what happens if one of these smaller, cheaper payloads is malicious in some way. And in particular, what we're going to be looking at here is what someone could do with the Cubesat to harm the safety of the overall launch mission. Now, there are a couple of reasons in the paper that we published in the CyCon proceedings that kind of talk about why someone would want to start with Cubesats. The most obvious is that they're fairly easy to develop exploits against compared to more traditional satellites, because your very big satellites are going to be bespoke, kind of one-of-a-kind projects, whereas Cubesats are going to use components that are purchased from a handful of commercial off-the-shelf vendors. And so an attacker might be able to also purchase those components and start designing exploits and figuring out vulnerabilities in those systems. This commercial off-the-shelf supply chain is also relatively vulnerable. The components might be able to have hardware backdoors inserted into them in a way that a one-of-a-kind part manufactured by Boeing or Lockheed is not really going to be as susceptible to. Additionally, the organizations building these devices are not necessarily terribly experienced at defending against cyber adversaries. We're talking about a lot of very small space tech startups or universities. And you can imagine a university that would take a visiting researcher, for example, working for another country's espionage wing and not recognize it. And that kind of insider threat is incredibly difficult for these actors to defend against, especially when you compare that with the defense contractors and the bigger aerospace entities who are at least aware of and working on these threats. However, all three of these things might not matter if you're a nation state and you want to use a Cubesat to harm a rocket, because Cubesats are relatively cheap. You can spend a couple $100,000, a couple $1 million building a malicious Cubesat and potentially be able to reap billions of dollars in harm and reputational damage against an adversary. And if you fail, the risk of failure is very low because all of the forensic evidence of your attack is floating somewhere hundreds or thousands of miles above the Earth's surface and will probably never be found. So let's go ahead and deal with one problem here, which is that, yeah, you might be able to compromise and build a malicious Cubesat, but what can you do with it? This quote here is very common in the space industry, and it's not wrong. Cubesats are largely useless devices for an attacker. They don't have maneuvering capabilities, so you can't crash them into things. They're very low power, which means that you're not really going to be able to do a lot in terms of either causing kinetic explosive damage or even in terms of transmitting stuff. And the hardware on there is not very novel or interesting. It's going to be mostly cameras and antennas. These aren't sophisticated devices compared to larger satellites. However, when someone asks a question like this, as a cybersecurity person, my gears start turning. And so in our paper, we delve really into this question and think about what you could do as an attacker with the constrained capabilities of compromised Cubesat hardware. So the way we go about this is we first try to figure out what it takes to build a Cubesat safely. And there are a lot of safety standards that have been developed for Cubesats. This makes sense because the people who are building CubeSats aren't generally terribly experienced with space stuff. They'll be like universities or kind of smaller businesses. And the people who launch rockets really don't want these CubeSats to break in a way that could harm the overall mission. And so there are reams and reams of safety standards and requirements that CubeSats are supposed to be built to in order to protect the overall mission from the malfunctions that will inevitably happen in some people's CubeSats. However, from our perspective in the paper, if we invert these standards, they're basically a guideline on all of the things that an attacker might want to try to get a CubeSat to do and then conceal that capability. So in the paper, we actually break down these standards and go into depth into a handful of them that are directly susceptible to kind of cyber exploitation, a little bit more easily modified in software. And we focus in particular on radio communications, because that's where a lot of our research happens in other topics. So it's somewhere we're comfortable on. And the radio safety standards are really intuitive here. So, for example, CubeSats are not allowed to transmit radio signals for like 45 minutes after they separate from a launch vehicle to reduce the risk of radio interference while the CubeSat is close to the rocket. However, as we delved into these standards, we found that the actual process for verifying that these have been met often just boils down to paperwork. The person who builds a CubeSat has to do a lot of paperwork about how it works and how it's designed. They provide that paperwork to a launch integrator who then decides whether or not they approve the device based off the paperwork. And this works really well if everyone has the same goal of reducing their liability and ensuring that the launch mission is safe. But if the operator has been either deceived into believing their CubeSat works in a way different than it actually will in orbit, or is deliberately malicious and trying to deceive the launch integrator, this system is not quite as robust. And in our paper, we delve into a lot of different attack scenarios that I'm not going to get into here, talking about how those deceptions might happen. But the main takeaway, I think, from this process is this idea that when the responsibility for truth is so hard to independently verify, right? You can't tear apart every single CubeSat before you put it onto a rocket, or you'll never launch your rocket. You end up having these opportunities for trust exploitation. And the next thing we do in our paper is we try to see what would happen if you got away with breaking a handful of these rules. In particular, a rule about when you're allowed to transmit and a rule about what frequencies you're allowed to transmit on. What could you do with CubeSat hardware? So we walk through a simulated attack scenario. And the first thing we do is we posit that there is a CubeSat that has basically two hardware requirements. It needs to have what we call a software-defined radio, which are becoming relatively common in space because they allow you to adapt your frequencies programmatically, and also have an antenna with operating capabilities inside a certain frequency range. It's very likely you could find someone else's CubeSat that has both of these properties, and it would be fairly trivial to build your own CubeSat with these properties if you invested the money into it. During the first stage of launch, our attacker's malicious CubeSat will behave like every other satellite. It won't do anything wrong until the moment it separates from the rocket in orbit. At this moment, it's going to start transmitting radio signals 45 minutes sooner than it's supposed to, according to the Cubesat design standard. And those radio signals will be selected to cause interference with the L1 band of the GPS, or Global Positioning System, with the goal of degrading the reception of GPS signals on the launch vehicle that just pushed that CubeSat into orbit. The ultimate objective for the attacker here is to try to trigger an anomaly in the ability of the rocket to tell where it is. And this is really scary because rockets are really scary. When you think about a rocket that's launching a satellite, it's not all that different from an ICBM other than the direction it's pointed in. And so if you don't want to accidentally start World War III and your rocket looks like it's straying off of its intended path, you will normally terminate your launch mission through a flight termination system. So that means you'll literally trigger a self-destruct sequence that combusts the rocket before it can hit the ground. And sometimes this is some guy on the ground with a big red button, but increasingly we're seeing something called an autonomous flight termination system. And these are devices that remove the humans from the loop here. And basically, if they detect a positioning or movement anomaly on the launch vehicle, they can just trigger that self-destruct sequence automatically. Now, the details on these autonomous flight termination systems are very much not public information. So it's hard to know exactly how much of an anomaly or what sort of anomaly would be used. But we think that at least an attacker could degrade the reliability of these systems, which definitely rely on GPS, as one key telemetry feed. So to model this, we need to understand whether or not a CubeSat could actually mess with GPS reception well enough to trigger such an incident. And what we ended up doing is we built some astrodynamic simulations. The first thing we had to simulate was that process of the CubeSat separating from the rocket. Turns out this is surprisingly low tech. CubeSats are basically put in these little tubes with a spring on one end and a door on the other. The door pops open and the spring just kind of gently shoves that CubeSat out into space. And our attacker is going to be targeting this early window when the CubeSat is just starting to drift away from the rocket before they're supposed to be able to transmit radio signals. The next question is how much power the attacker needs to be able to get that radio transmitter on the CubeSat to deliver to an antenna on the launch vehicle. And there's not a lot of great evidence as to like how much reception you would, or how much power you need to transmit to interfere with GPS reception in low Earth orbit. But there was one study done by the US Department of Transportation on a nearby frequency band related to LTE cell towers, which estimated at kind of that dotted line you see on the graph there as where you'd start to see problems in GPS reception. Which means that our attacker, who's targeting the exact same frequency bands, this isn't accidental near-band interference, this is intentional in-band interference, will probably be able to at least cause trouble during that 20 to 40-minute period, depending on what transmitter they have. Another way we look at this in the paper is to look more on the reception side of things and to calculate the signal to interference plus noise ratio of the receiver. So the dotted line on the top there is how the GPS receiver would be getting information if there was no attacker in the scenario. And then the bars below are different power levels. And if we compare this to the kind of parameters of a standard or high-end commercial GPS receiver, we can see kind of that the attacker is able to at least degrade the signal into that kind of yellow zone on the graph here, where it's not great, but it's not perfect, with a low power transmitter. And with a higher power transmitter, might be able to cause sustained disruption or complete elimination of GPS precision. And the amount of time there can be anywhere from 40 minutes to hours, depending on how close they're able to maintain positioning to the vehicle and how strong their transmitter is. So there's a lot more work to be done here. One thing that we could think about is how we might prevent this attack via technical means, looking at anti-jamming techniques in those flight termination systems and GPS receivers on rockets. Another thing we could think about is how we might prevent Cubesats from behaving in this malicious way, perhaps with a bill of materials that's pre-approved, with antennas that can't communicate in the GPS spectrum, so you don't have to worry about unintentional or intentional interference. We might think about ways that we can improve our attribution of this kind of attack scenario to increase the risk of deterrence from a nation-state actor or someone getting caught doing this, so that the forensics evidence isn't completely out there in space. There might be something on the ground we could use to attribute it. And then we might also think about how we could revise the way we certify and approve Cubesats to account for this kind of risk. And I think a lot of the panel discussion will be about kind of figuring out what sort of things we can do against these types of threat models without breaking the ecosystem that has made small satellite launches possible. So to sum things up, I think there are three general takeaways from this research. The first is that safety and security are not always the same thing. Cubesats are designed to be really, really safe, but the way that safety is verified is not necessarily robust against an adversarial attacker who's trying to lie or deceive their way through a safety verification process. Additionally, when we see changes in technologies, like the emergence of software-defined radios for Cubesats, that doesn't necessarily change the safety standards, but it changes the capabilities and the adversarial risk of these devices. Finally, it's really important that we try to make these trust assumptions explicit. I'm not saying that we shouldn't trust anyone. We need to trust people to get anywhere in space or otherwise, and shared launches have opened up a completely different type of space development than we've ever had. But at the same time, when we are making these trust assumptions, we need to understand what risk we're bringing into our missions and then account for that, whether it's through policy or through technical mitigations. Thank you so much for listening to this presentation, and hopefully it was interesting.
James, thank you. And thanks to you and the team at Oxford for a great piece of research. It's amazing how many fantastic cybersecurity discussions are followed by the sentence, "What's the worst that could happen?" Especially when that's in some of the really innovative and cutting edge areas of technology. So Picking up on great piece of research and a great presentation, we've now got a panel where we're going to bring in some great sort of thinkers and people around this area. I was about to say around this space, where we're going to start exploring some of these concepts and ideas that James and the team have come up with. So who we have in the rest of the panel this afternoon is we have Erin Miller. She's the Executive Director of the Space Information Sharing Advisory Centre. We've got Ryan Spielman, who's the Principal Director of the Cybersecurity Subdivision at the Aerospace Corporation, where he's focused on the security of space-based systems. And Andrew Santangelo, the CTO of CyZone, providing a variety of Cubesat and smallsat services to both civil and US government customers. So I'm going to pass over to them to do short introductions of themselves, and then we'll get on to the panel. So Erin, you first, please.
Hey, good afternoon, everyone. Thank you for having me. As Pete said, I'm Erin Miller. I'm the Executive Director of the Space ISAC, and Space ISAC is Space Information Sharing and Analysis Center. My background is in public-private partnership and currently doing that with the Space ISAC as we're bringing together commercial and international and government collaborators to share incidents, threats, and vulnerabilities across the global space community. So I'm very pleased to be here. Thank you for having me.
Thanks, Erin. And Ryan.
Hi, yeah, thank you for having me. I appreciate being here. Ryan Spielman, I'm the Principal Director of the Cybersecurity Subdivision at the Aerospace Corporation, which is a federally funded research and development center where we interact and operate in all aspects of typically U.S. government space. In my organization, we're typically involved in the security of spacecraft, legacy space systems, next generation space systems. To include launch vehicle, although we've done a lot more research and development in the space segment, spacecraft security, and things like that. But again, I'm looking forward to the panel and appreciate being here.
Thanks, and thanks for being here as well. So Andrew, finally over to you.
Yes. Yeah, good afternoon, everyone. And again, thank you for inviting me to speak at this afternoon's workshop or conference and session. I'm Chief Technology Officer of CyZone. And also, I'm the founding chairman of the American Institute of Aeronautics and Astronautics Small Satellite Technical Committee. And so I've worked right from the very early days with Cubesats and small satellites, especially Cubesats, as they've gone from more low in numbers to suddenly blossoming to universities and hobbyists and businesses and of course, the government level. And more recent work has been, of course, I've had a few Cubesats go up into space, and now working on the cybersecurity front, creating a sandbox, actually, that simulates the actual different segments, the ground segment, link segment, and space segment for Cubesats and small satellites. Again, thank you for inviting me today's conference and session.
Brilliant. Yeah, and thanks to all the panels. So you can see that across everybody from the academic to industry to the community, we've got a great representation. And actually, the way that we're going to structure the panel is that first we'll develop the idea, and then we'll start talking about how do we make this risk a manageable risk and also continue to grow the sector, and then really trying to set the scene for everyone listening about how we tackle some of these challenges at scale and collaboratively. But first of all, I'm going to be coming to Andrew, where having been involved in the small sat community for a long time, can you really sort of set the scene about what the growth is like in this small satellite, big satellite world, and what a difference that the ride sharing has made in this area and how people are approaching it?
Yeah, starting off, remember, we have to look at the situational landscape that Cubesats, and I'm going to take more on Cubesats, but it does cover small satellites too, up to 500 kilograms. Yes, that's a small satellite still, where we cover scientific missions, military operators, education missions, loads of commercial enterprises, civic operations, and of course, even hobbyists. So when we think of Cubesats and small satellites, we have down to a picosatellite, which is under 1 kilogram, to nanosatellites from 1 to 10 kilograms, microsatellites to 100 kilograms, and of course, a mini or a full-up small satellite up to 500 kilograms. And originally, we were looking at, onesie, twosies, maybe 10 or 20 back in the mid 90s. But if we think of CubeSats and small satellites, where the PC industry was in the 70s, where again it's more of a hobbyist and kind of getting off the ground, and then it exploded into the 80s and of course 90s, where that same thing is happening with CubeSats, where now we're looking at CubeSat growth up to over 1,400 units a year by 2022, and mini satellite growth up to 250 units. Of course, this is all being helped with SpaceX, Starlink, and OneWeb and others. But there are certainly a lot of small satellites going into orbit, even the Pico satellites, where there'd be launch of even 100 at one time, all distributed at once to return to Earth within a day or two. And this is all being facilitated by these ride shares, both here in the US and internationally. So there is a broad spectrum. And of course, with that large number, great vulnerability in the situation in all three segments. Again, the ground segment, the link segment, and the space segment.
So that's just really showing the massive growth that we've got across all of those stakeholders in that ride-sharing world. So, I mean, Ryan, coming to you from your perspective on that journey across all of the stakeholders through all of the payload operators and all of the launch vehicle operators, that's quite a complex world when it comes to how they're all interrelating and forming those trust models to actually get the payloads into orbit. Can you talk sort of more through that perspective as well?
Yeah, of course. So like you said, it's a complicated set of interactions, right? You have, first, just starting at the launch site by itself, there's a lot of things going on the launch site, a lot of support equipment. There's a launch vehicle provider, typically the rocket owner. Rocket launch is going to have a primary mission, which may include one or could be more spacecraft on a primary mission. And even though spacecraft could have multiple vendors, themselves could have multiple payloads, and I'll explain what I mean by that in a second. And the primary mission typically certainly has multiple stakeholders as well. And that's not even getting into the ride shares and the Cubesats yet. So that's just kind of a default launch configuration. So these spacecraft are built by a vendor or a set of vendors. They're delivered to a launch site, and they may sit there for a while before they're actually flown. There may be a chain of custody issue where various people may have access to them potentially. And so when we talk about getting into the spacecraft themselves, again, I'll talk about Cubesats in a second, but the spacecraft themselves, they may have a single payload, and by payload, I don't mean that thing that you deliver in a cybersecurity attack. I mean the thing that's actually supposed to do the mission. They certainly have what's called a spacecraft bus, and these are the things doing the attitude control, the positioning, the command and data handling, all the primary things you need to do to have a spacecraft fly. They certainly have their primary payload. They could have multiple payloads. Then on top of all that, you get into this CubeSat world of okay, like James said, we want to share some launch vehicle capacity and split the cost. And there could be there could be tens of small sats and CubeSats, riding with them. The other thing to keep in mind, and James hinted at this in his original presentation, was the spacecraft themselves. The primary missions are typically close to one-of-a-kind systems, right? They're built by some vendor. They're there for a particular mission. They have a huge dependency on fault management, and in this case, fault management may or may not, really do the right thing when a security event, right? They're built for a random failure and a radiation event, something like that, and the fault management systems aren't specifically built for cyber intrusions. And then you have the issue of integrating these Cubesats that James was talking about. If one of them is malicious, what effects could they have on your primary mission? And the primary mission isn't necessarily built for defending against that. So there's a lot of things, a lot of different stakeholders, and each launch is going to be different. It's going to have different stakeholders. And it's important to kind of keep in mind all the different players in that area.
Thanks for that. And actually, that's a really nice time to segue across to Erin and the work that that you're doing with the Space ISAC, because you do have multiple sets of stakeholders in there, and looking to both share information, gain context, and try and build trust really across a lot of them as well. But do you want to talk about that from your perspective as well? And actually, how are you seeing people starting to talk about risk and balancing that across all of those different stakeholders, be that of different scales and size and across that supply chain as well?
Yeah, well, let me set the stage a little bit for you of what the Space ISAC looks like. When we launched the Space ISAC, it was launched by the S&T Partnership Forum, which is chaired by NASA. So we had an initiative from the US government calling the commercial and international and government contractors together to collaborate to share information with one another. And so part of the reason why they did that is they saw the lower barriers to entry to enter the commercial space economy, the proliferation of LEO, and the need for us to share information about cybersecurity risks and vulnerabilities in a trusted community. What we've done in the Space ISAC is we've created an environment where you have government and commercial and international coming together in different forums where they're able to share information with each other about what they're seeing on the horizon, the problems that already exist today, and provide them an opportunity where they get to know each other, and we're increasing trust on a regular basis by these regular forums. We also have a standing information sharing working group that has created rules of engagement. So we have what's called our operations and analysis framework, and we also have priority intelligence requirements. So we're scoping what's important to the community to share, and we're also giving them some rules to follow when they share information. So we can send alerts and notices to the global space community on the regular so that they have access to this type of information, allows them to respond to incidents. So that's some of the work that we started.
That's great. And actually across such a diverse community, I've got to say that isn't a small piece of work. So hats off to you and the team for really sort of getting that conversation going and starting to build that trust across that community. But what we've done really now, I think, is set out from both the research and the growth of the sector and some of that challenge out there, is that actually when we're looking at risk across the sector, we've got to try and balance growing the sector and growing that innovation and allowing that diversity to keep increasing, but also making risk manageable as well. And when James is talking about his research about the potential threat, but then at the same time, we've got Andrew talking about the different numbers of stakeholders out there, and even the small groups that are trying to do this in a safe and secure manner. How do we find the middle ground across all of those? So I'm going to come to you, James, first. And so if we're looking at the security of this sort of challenge, and you've been looking through this in your research, so can we make this a practical and viable approach to actually increase the security around these platforms?
Yeah, it's a very hard question. I think that we can definitely improve things. And it's very easy at a conference like CyCon to think that cybersecurity is hopeless, but we've actually gotten quite good at doing cybersecurity on the ground. And it takes a lot of effort for attackers to, especially when they're targeting one specific system and they absolutely need to get that system to be successful. And I think that we can learn a lot of lessons from terrestrial cybersecurity in space, and we can make progress, right? Like very basic things, encryption, logging, forensics, having those capabilities on our space assets can go a really long way towards making it much harder for attackers and more difficult. I think it can be very tempting to try to go with a complete security approach and want to lock down a system that is completely unbreakable. And we need to find a middle ground between the two to be able to have these very low-cost, innovative systems in orbit, which is also a goal that we should have when we're thinking about security.
But to follow up on that question, I mean, you picked up right in the presentation right at the very start. It's that trust model. So from the research that you did, at the moment, it's very much almost like a self-assessed questionnaire of have you done the right things. And I mean, from what you've seen and the research you've been doing with the team, do you think that is still viable?
Yeah, so I think that trust model needs some sort of pushback. I think maybe one way to do it is that you earn trust over time, right? So if it's your first CubeSat, maybe you do have to have someone else do what we call a day in the life test, where you essentially simulate the first day of your CubeSat's existence, and then see that it doesn't break. And later on, you might gain trust over many missions that you can do that within your own laboratory. Alternatively, you might have like a trusted hardware or a trusted software model where, in order to get rid of some of that, just you can tick the box saying my CubeSat doesn't operate during this time window and we'll spot you. Have software that cannot operate during that time window, and then check that the CubeSat is running that software as a additional threshold. And all of those can be circumvented. It's a game of cat and mouse, but it's nice to at least move the bar a little bit higher.
And I'm also going to pick up on something that you spoke to us about before the panel, which is when we're looking at actually getting the CubeSats out of the launch vehicle, actually it's the physical protections around those CubeSats as well, which as the drive for reducing weight has increased, then that has potentially increased the risk of RF interference. You'll just quickly touch on that as well.
Yeah, it's a really cool topic. And I think it speaks to this idea that you might change the technology with an effect that's basically the same for safety, but very different for security. So we're seeing those tubes I talked about in my presentation, the P-pods. They're made out of, I think, aluminum, and they're essentially Faraday cages. So radio signals can't get out of those tubes while the door is closed and the CubeSat's inside. But there's been some push towards changing the deployers so that they're made out of lighter weight materials like carbon fiber, or even they're open on the sides to reduce the weight because you don't actually need the side bits there. And those changes don't do anything for the safety of the CubeSat. It's still locked into that tube until a door opens. But now a radio signal can get out of the tube because maybe the material doesn't create a proper Faraday cage, or it's open on one side so the radio emissions can get out. And then you can start jamming while you're on the launch pad or something, which is much, much more dangerous because the range safety tolerances that close to populated areas are going to be much tighter.
So again, it's one of those areas where physical changes and then the potential onward changes from the adversarial point is making the mission quite complicated when it comes to the risk and trust models. So Andrew, coming to you from that community perspective and actually building, creating, launching all of these different payloads, what sort of impact is this sort of thinking potentially going to have on the community?
Yeah, I don't want to sound like a Debbie Downer or anything like that, but I do see more and more with both, let's say, players like NanoRacks in the United States and also NASA and their independent verification and validation facility and the launch providers doing more independent verification of the CubeSat and small satellite being compliant not only on the safety side, but a cybersecurity side that might overwhelm a lot of lower cost players, lower revenue players. So that hobbyist that did a fundraiser for their CubeSat may not even make that threshold, and even tougher for a lot of universities as they go through this process. And it certainly be a great learning experience for all players to learn what's involved in a verification validation process. But I see that becoming more into play. And I even feel, even with you're talking about changes in the P-pods for ejecting the CubeSats and small satellites. In a sense, I go back to in the shuttle days when launching a small satellites, that in the end, it may end up being a very tight container. Even though it's heavier, it still is a protective carrier container from the launch vehicle and the larger payload by keeping that small satellite shelled in, because it can be a very capable system to bring down a launch vehicle, a large satellite, or really anything. So I see more effort on more restrictions in that process, but also as a community. For example, I'm working on an effort to create the cybersecurity sandbox using our LinkStar system, where we actually have a real CubeSat, though it's on the ground, that simulates the space segment. We have an element that simulates the link segment in partnership with Globalstar. And then the ground segment, setting up secure ground servers for the mission side, where people selected groups in the larger small satellite CubeSat community, where we constantly probe those vulnerabilities and try and address those back to the community to make it easier, at least for a smaller player, like universities and hobbyists. When I say smaller players, still could be a large university, but still compared to like your NASA, Department of Defense, Boeing, and Lockheed Martin, where they have a much larger budget to work with than these organizations, at least have this sandbox environment. And we're going to be talking about this and sharing this several times throughout different conferences throughout this year, actually, where people can get involved and then share that with the community, the small satellite CubeSat community.
So can we just, one of the things that we've picked up in previous conversations is, can we just touch base on the cost of a typical CubeSat mission? Yeah. Because again, it's one of those things that we keep talking about democratization of it, actually, but just can you just throw out a couple of numbers of, right, let's get a CubeSat airborne. How much is that going to cost? Because people think I think it's cheap, but really
originally, when I worked with this, whole idea is raise, $50,000, get launched, get a free ride, you're good on the CubeSats. But what I found in several missions is the real cost has gone to a university anywhere from $250,000 to $1 million, and that's just partly due to the expense in the process, not the launch costs, but more just in getting the resources lined up and managing it, even flight qualified hardware, and then issues related to that aggravate and stretch that time to develop, including, for your university teams, they're still going to school, they still have classes, they still take a holiday, they have, their final exams, and then some of them even graduate, and then so those cause all these added delays, which drives up the cost for a mission. So what I am telling a lot of universities, if they can get into space, that is a major milestone just to get into space. And if they can get their small satellite, CubeSat, to say hello world, that's fantastic. Unfortunately, there's a high failure rate with CubeSat and small satellites, which aggravates this whole situation. And so we're trying to address this as a community to better identify the problem. And then now you throw into all the cybersecurity that has to be concerned with this process, again, with the ground segment, the link segment, and the space segment. The goal is, as a community, how do we manage that and share that to help take the load off of all the various players, including those who want to get started in this CubeSat world. So it's kind of like where I said the PC world was in the 70s, where you had all these hobbyists and building boards and everything, and then how it streamlined out. I think we're seeing that same sort of situation take shape in the CubeSat and small satellite world. How that addresses your
brilliant. No, that's a great answer, and actually, it goes to show that actually there's lots to discuss when it comes to risk and managing risk across all those different stakeholders. And Ryan, can I come to you on that from your background and your perspectives, because there's a huge amount of risk management across all of those different stakeholders, but they're all looking at it through their different perspectives. How do you sort of see that across all of those different stakeholders, considering the criticality of a lot of those missions and the high cost involved? Is this something is there a common view, or is there lots of different views at the moment?
Yeah, for sure. And risk management is all about intelligent risk management, right? I've seen risk management done intelligently, and I've seen it done where it's just kind of it ultimately creates a paperwork drill, and it just drives up your cost, right? So, starting with even the economics, you can't pay $1 million for independent verification on a $250,000 CubeSat. The economics just doesn't make sense. And certainly, if that's what it would take in order to get a rideshare to work, then I'm never going to pair a $250,000 CubeSat with a $100 million spacecraft, right? That just wouldn't make sense, because the cost that they're going to absorb in the rideshare isn't gonna pay for the independent verification. So I think we need to get back into intelligent risk management. We need to think about what threats are realistic and which ones you should pay to mitigate. And there are ways to mitigate all these threats, and there's a cost associated with them. Standards are part of it, and they're great. And we should probably have more, launch specific standards in terms of security. But again, that gets into intelligent risk management. You can pay for the wrong things. You can make a $250,000 Cubesat into a $1 million Cubesat and still not actually mitigate any of the important threats. So as an example, James laid out a very specific scenario where a Cubesat will maliciously broadcast in the GPS L1 frequency right after separation in order to affect the launch termination system. And that's a very realistic scenario. There are ways to mitigate that particular scenario. So, for example, I could force a independent input and into your RF chain and verify. So I could ask you, for example, to specify what filter you're using, to specify what antenna you're using, and just at a paperwork level to demonstrate, okay, that there's a tens or probably 100 dB loss at that frequency. And of course, you as a malicious actor could put the wrong part in or could lie about what the part was. Well, I could have somebody test that. And it wouldn't be very expensive to have somebody do an independent test on that by putting in their own input and testing your RF chain and demonstrating that it goes through your RF chain. And I could do that at the launch site, and I could maintain a chain of custody so that you couldn't go back and put new filters and antennas on there. That's going to cost some money. It's not an exorbitant cost. If I go off and do that for every threat anybody could possibly imagine, whether they're realistic or not, then I'm going to end up with $1 million of cost. But if I just go through, 4, 5, 6 things that I think are realistic, then you can actually have independent verification for a reasonable cost and not completely destroy the economics of your rideshare.
There's so many good points that come out of all of that, and I want to sort of like pick up on those in probably the next set of questions as well. But Erin, coming to you, you've got a great community building up around you and the work of the Space ISAC across all areas of the sector, and a lot of that will be talking about the trust, as you've already highlighted, but also they're all managing risk as well. So how are you seeing that growth of trust and discussion about risk management across the sector? Because certainly looking at, for example, the work that Jeff has done with the aviation ISAC, building trust and building those communities is a huge challenge, especially on things that are critical and involving safety as well. So how are you seeing the industry and yourselves approaching building out that trust and that really good information sharing?
Yeah. So in the global space community, we know there's a lot of different subgroups. And one of the subgroups you could say would be like U.S. defense contractors. They're quite a large group. And they've been managing risk in their own way for a long time based on military requirements. But when it comes to the commercial sector and non-military implications associated with launching vehicles in space and putting payloads in space, then there's a whole different environment, as has been addressed on this panel, with the small sat community being primarily composed of small businesses, startups, and spin-outs from universities or university research settings. So what we've done in the Space ISAC is we formed a small satellite owners and operators community of interest, and non-small sat owners and operators are welcome to join this community of interest. So we're looking to bridge a large group of folks that normally are not engaged in small sats with the small sat community. And that also includes our public sector partners from across the world. So when we form this group, then from the outset, it is a public-private partnership. So government and the small sat community coming together to be able to talk about cybersecurity. And our going in approach for this group is not to talk about standards, it's to talk about best practices, create awareness, education, and just have a forum where we can talk about threats and vulnerabilities, because that may not be an opportunity for someone who's in the small sat community to every day have a place to go where they can just chat. What is the risk associated with a certain function of their small sat, and what are the threats and vulnerabilities that they need to be aware of when designing cybersecurity in to their system. So this forum that we've created is intended to not necessarily impose standards in the short term. It's to create awareness, and over the long term, we should start considering, and this group will be encouraged to share information between the public and private sector so that the standards are informed. Because as we continue to progress down this path where there's more implications on civilians for the use of space systems, then there will be things like space systems being designated as critical infrastructure is something that's being discussed. And so we're very well aware in Space ISAC that there's the potential for regulations to come from that designation. And although it's very important, we want the public-private sector conversation to inform the regulation. So this gives the startups, the university setting, the small businesses a way to inform the direction that we're going.
Thanks, Erin, and that's actually really nice to hear. I mean, already if we sort of just reflecting on the panel, we've got some great research from James and the team at Oxford highlighting some really good challenges, and we've got a thriving and growing sector and community around there. And already in the Space ISAC, you're having those discussions and forming those communities. So for the people who are listening, hopefully we're showing that there's already spaces out there to be able to discuss and move forwards and collaborate on these areas. And it's interesting, we've had one question come in that talks about how do you keep Cubesats free from compromise and malfunction, and ideas and suggestions, which is great timing because that pretty much aligns with the final bit of the panel. And I mean, the first thing I'd sort of highlight, I think that across all of this is I tried when we've done stuff like this in the past, it's try not to think about your satellite as a satellite. Think about it as a computer that happens to be in space. When you're talking about your aircraft, don't think about it as an aircraft. It happens to be a computer with wings that flies around the world, and your ships and your boats. So it's really, if we treat them like computers that we're putting in physical proximity to other computers, actually, how do we start making this something that is easy for all of the different stakeholders to do to secure these and reduce almost classes of vulnerability through either design or safety considerations. So really sort of to go through the panelists, the sort of last set of questions is, how do we take this forward? And how do we really start to not just sort of manage the risk and prioritize the risk, Ryan, as you were saying, but also really start reducing the risk so that we keep the barrier for entry low for all of these different communities to be involved. I'm probably going to come to you, James, first to see what you think from your perspective on this of actually what would be some good things you would want the community to do out of this.
Yeah, so I think Ryan's point about figuring out which threat models are credible and then prioritizing them effectively is really the key here, and trying to create an ecosystem where that's possible. So I think that involves people doing offensive security research, making this information available for researchers or doing it internally even, and then working on defenses and mitigations as a secondary step there. And I think the way that we make it affordable and accessible is thinking about ways that we can standardize not just a you should do X, but you should do X by Y. So come up with very basic rules of the road and best practices that people can incorporate into a lot of space missions. Because you're right, they're all fundamentally computers in space that are very similar in a lot of ways and very different in very small ways. And if we can make that similar bit secure, then we can focus on the differences as kind of icing on the cake.
Brilliant, and thank you for that. And Andrew, I'm going to come to you next from that community perspective, because as you've already sort of raised, it's that there's not a lot of margin in making these things and trying to launch these things, and actually people are still learning and doing this as a learning project. I'm thinking in my head we can use this as a cybersecurity learning project as well, which is great for the sector as a whole. But how do we help ingrain that into the community and get people thinking along these lines?
Right. Well, one thing that's happening, like I've explained earlier, is we've now are opening up a sandbox, so to speak, a cybersecurity sandbox for CubeSats and small satellites with an actual CubeSat small satellite, albeit on the ground, not in space, that covers all those segments we just talked about earlier, the space segment where the satellite is, or it could be a rover or what have you, the link segment, and then the ground segment. And instead of sharing that sandbox and discussing it, once every conference, every few months, like here at CyCon, our goal is to build that community and have it active throughout the year, and then share those results and best practices at each conference. So, for example, we have an actual Hackasat event coming up at DEF CON this August, where we're taking all the lessons learned, right, and how that and share that to the community, and then following that same week with the Small Satellite Conference, again discussing and presenting the cybersecurity sandbox and lessons learned during that time, and then that's following with the Ascend Conference. So it's not stopping at these conferences and workshops, but rather keep the sandbox thriving, have a discussion within the community. As a matter of fact, one group of us were meeting weekly and updating on all our work. When I say a group of us, this includes NASA JSC as part of this, MIT. I guess now we're adding Embry-Riddle, name the university, they're all part of it. And certainly everyone who's part of the Small Satellite Technical Committee, which is a very broad audience. And then that fans out to the broader community. And again, when we say small satellite, we're talking CubeSats, nanosats, and picosats. So we see this sandbox as a great way to help set those best practices and standards and lessons learned to make it easier for even players like hobbyists in universities and small businesses to get involved, and even large organizations like Lockheed Martin or a NASA or a Department of Defense.
Thanks for that. And that shows a lot of that good work in the community. And Ryan, coming to you, but one of the things that you've touched upon is the amount of effort, and we've spoken before about the focus on safety and the focus on mission across all of this. And there's a really clear delineation of accountability and responsibility in all of those areas. How do you try and get that thinking across into that boundary on the cybersecurity aspects in this area? How do we make cybersecurity on these platforms and these launches and the integration of the payloads and launch vehicles as natural as we think about safety and mission criticality?
Yeah, it's a good question. So, part of it is standard and community, which the other panelists have mentioned. A big one I think is to think about things from an adversarial mindset, and also what could the CubeSat actually do. So you could classify threats, and the paper actually does this. It classifies threats as kind of the outside threats where you have no access to the hardware. You put a malicious software payload into something, versus an insider threat that actually could modify and mess with the actual hardware. So the former has less than it can ultimately accomplish. I can't modify the hardware remotely. But the latter is much more risky, right? You can end up in jail or worse if your threat is successful and they figure out what happened. And so I think if you think about things from the adversarial mindset, you can limit the actual realistic threats into a tractable set of things. And then the community can get together and come up with some standards around how do you mitigate those specific threats that are practical, and also of course come up with, well, what did we not think of? What are the other set of threats that belong there? But I think if we do that, then we can go through and classify the threats and the mitigations against them into a realistic set. And I think that would be the key.
Brilliant, thank you for that. And then sort of finally, Erin, coming to you, is you're seeing the growth of this area. You're seeing all of that collaboration, in sort of casting your eye forwards with where you've got the Space ISAC going in that direction with the community. Is this a goal that we think can be achievable?
Yeah, I'm very optimistic, and yeah, I think right now what it does come down to is people need more visibility on what the threats and vulnerabilities are. And James' paper was fantastic for creating some of that awareness on a specific topic. And so because there are so many other opportunities and threat vectors out there and attack techniques and tactics, then you leveraging the resources that are available to the community is the thing I would encourage the most. And so since that's what we're doing every day in Space ISAC is creating resources, then I just encourage people to think about what is becoming available to them through this great platform that we're building. We have a threat intelligence platform where we're sharing alerts. We have an analyst working group that meets every month to talk about threats and vulnerabilities. And so creating a forum like that in our small sat community of interest is probably the future for small sats, where they have regular access to that, those threat briefings. We also have been working with folks that are normally not providing information previously to the general public, and they're now willing to speak on threats and vulnerabilities to the general public, recognizing that this information is out there and it needs to be provided. We need to provide access to it on a larger forum, or in larger forums, sorry. Longer term, then Space ISAC actually next year will have a watch center. And so that watch center will be staffed with about 5 to 7 analysts, and we'll pursue other activities. We have great opportunities to do what other ISACs have done for their sector, like create benchmarking and create cyber hardened platforms to make those available to their sector, and make it easier for small businesses and university type settings to be able to have access to lower cost resources.
Yeah, Erin, thanks. And that all sounds really exciting. And I think that also it's not just that small sat community that you've got in the Space ISAC. It's also you've got the big industry space players in there as well, which I think is really great. And that is if you look at the breadth and depth of that community, I think that there's a lot there. So I mean, panel, that's been amazing. James and team, great piece of research. And I think to sort of like summarize is that it still feels that we're in the foothills of talking about this as a great and innovative and fascinating area for not just research, but also building up that thinking and that sort of set of people that really understand this intersection between space and cybersecurity, because we're equally dependent on both really this going forwards. So lots to talk about going forwards, but also we've given lots of really good, I think, insight to all of the different areas where people can actually go and see more about it and read into James's research. So thank you to all of you. Have a great rest of CyCon, and thanks to you and the CyCon team. So now there is going to be a short 20-minute break, and then at 17:20 there'll be a great discussion with the representatives of the US Cyberspace Solarian Commission that you'll be able to follow on stage 1. I've been P. Cooper, and this has been Cyberspace Cubed with an amazing set of panelists. So thank you very much.
Thank you.
Thank you.
Thanks.